Hello, my dear students. It's nice to see you today. Today, we have a new chapter. Do you think what this chapter about? We will talk about the important one for equilibrium. Concentrate for each part. Be careful for the equation for explanation. The first lesson will be about effect of the pressure. Great to talk about this fantastic lesson. When you have beaker, this has water pool. Now to know the effect of the pressure water, add water to this pool and wait what happened for this. And what we conclude, this beaker contains water. Put water for about 60-80 centimeter cube to the beaker or to the pool and wait and record the time. Empty bottle, I put it for the pool, and be careful what happened through this experiment. We notice that the amount of the water is absorbed by this bottle. Absorbed how? We can say the water has high pressure, the bottle low pressure. We know it transforms from the high to low, from the high pressure to low pressure. So the whole amount of the water in this pool will travel to the bottle. Ask why that? Because the pressure here is higher. From the high pressure to low pressure, the temperature increase, the pressure increase, and there is a change for the water. This is a doublet for the first one. Do you think the absorption here is stay or it changed? That what we need to know from this experiment. You can say concentration of substance in solution is given in terms of molarity and expressed by placing the substance between two square brackets. Now it becomes higher, the time increase here, and all amount of this water is absorbed. So you can say this is back to the pressure which help for transferring from the high to low. Now, my lovely students, the reactants, if the reactants or products are in gaseous state, the concentration is expressed by using their partial pressure. Also, you can say the concentration of a substance in solution is given in terms of molarity and expressed by placing the substance between two square brackets. Don't forget, not any bracket, must be a squared bracket to catch the concentration. Now, look at this. Increasing the pressure or cooling, do you think what is the effect? Let's to shift the equilibrium in the direction of reducing pressure. Take care. Another one, decreasing pressure or heating on gas reaction. What happened? This is let's to shift, increase. Increase what? Increase pressure. Decrease or increase pressure depending on the heating or the cooling. Another one, we have an important example. N2 plus 3H2 will be 2NH3 plus delta H. It means negative 92 kilojoule. This equation, what you need? We need from that. So, KB for this case equal, good my dear, P concentration in H3. Don't forget to put the water, this power, divided what? Divided the concentration of P N2 by concentration P H2. Don't forget the power for each because it has a highly or difference effect. This is the effect for equilibrium pressure. Now, this power for the product and this power for the reactants. Another one and another important example. Calculate the equilibrium constant Kp of the reaction. what this reaction about? N2 plus 2O2 will be for two directions 2NO2. Now, what do you need? Answer. Solution. Kp, constant equilibrium, Kp equal concentration of the product P NO2, yes, the power divided what? Concentrated of the reactants P concentrated N2 by P concentrated O2. This is only? No, we have a power all time 2 for the product, 2 for the reactants to make a highly difference for the result. This is important to find the concentration. Solution. Kp for the other one, 2, yes, divided, yes, this is 2 concentrated power 2, divided the reactants, it means concentrated 0.2 by 1 power 2. The result for this case equal 20. It's very easy to find constant equilibrium. My lovely students, it's very easy to catch this example. Another one, 2 for up, 2 for up, it means don't forget the power. Another one, we can conclude from all of this that as a beginning, increasing the pressure or cooling on the gaseous state. This means what? Reaction at equilibrium shifts the equilibrium in direction of what? Of the other. Of what? Reducing the pressure, the direction in which volume? Less. Or the number of the molecule is less. Very easy. My dear, what about decreasing pressure? While decreasing the pressure or heating on the gaseous state, do you think what happened? Reaction at equilibrium. Do you think what happened? Shift the equilibrium in the direction of increasing pressure. Easy, and to make a comparison between them. Look, my dear. The direction in which volume a more or a number of molecules is more. What happened for this case? Take this example to explain for you. Calculate the equilibrium constant Kp of this reaction. H2 plus 2O2, the result for different direction 2H2O. Now, solution. Kp concentrated equilibrium equal PH2O 2 power 2 divided what? Divided these reactants PH2 by PO2. Now, the power for the concentrated of O2, PO2, power for HO2. Now, these powers explain this reaction. It's very important. Don't forget it. All time I say that. Solution. Kp 4 concentrated 4. Don't forget the power over concentrated of the reactants 0.3 by concentrated 1 power 2. The result equal 50.3. This an example explain what happened during the pressure. Very important to answer all of this. Now, the power up, the power down to find this result. Fly, my lovely students, for the other one. Le Chatelier. Le Chatelier is a good scientist to explain the chemistry. Le Chatelier. This man explained a lot of experiment about chemistry. French scientist formulated a rule named after him. If you have two tubes, cobalt chloride, yes, and water, 6 water, and I try to say what happened during this reaction. Cobalt hydrated water COH2O by 6 positive to be COH2O6 positive in chlorine. When it added, the color is changed. Cobalt chlorate and water will be COH2O by 6 positive plus 4Cl negative. Question here, do you think this reaction is changed like you see? Why? Why this reaction change from one to another? You can say it changes in any of the condition of the chemical reaction at equilibrium, such as will shift the equilibrium in the direction of the opposite in this change. This is help to tell you any change during this reaction, help this reaction to make in the opposite. What is the opposite? The concentration, the pressure, the temperature shift equilibrium were in direction of the opposite change. Now, there is a changing for different color by adding Ag positive for this cobalt water hydrated. You see the color change. Ask, why is it changed? Is it changed to make equilibrium, to make constant equilibrium? COCl4 negative plus 6H2O will be in different direction. COH2O by 6 positive plus 4Cl negative, which react with Ag to be AgCl. When I get this and add it for the beaker, this beaker contains the water as you learn it. Be careful and concentrate for the color. Look at this. Add it for the water and stir it. This hot water, the color is changed, become blue, dark blue. This is endothermic. In hot water, it work in direction of endothermic. What about if I take this and I put it in cold water? Cold water, the reaction will work in the direction of exothermic. Cobalt chlorate plus 6H2O water. Now, this rule predict the effect of the different factors such as concentration, temperature, and pressure on the system at equilibrium. My lovely student, Le Chatelier, it is stated that the change in any of the condition at chemical reaction at equilibrium, such as concentration, a change in concentration only? No. Also pressure, also temperature. What happens if it's changing for all of this? Will shift the equilibrium in the direction which opposite the change. This is Le Chatelier, wonderful scientist. Another important one, this is equilibrium. This balance, but it change if this man it move, the changing. When he make a digging for this, in the first one he make large dig and the amount of work increase. So the other man moves slowly, so the amount of substance increase. If he increase its work, it change its direction. Look at this. Now, this is equilibrium. When I increase this side, this right side, there is no balance. Make it both equal, there is balance. Le Chatelier principle. Stress. A change in concentration as a changing for the acid in the test tube. A change for the pressure, make it changing in constant equilibrium. Two factors. Number 3, a change for the temperature, we make a change for equilibrium. Reversible reaction tell me that if I have A in a substance plus B, both of direction will be C and D. Look, AB from this size, there is no equilibrium here. I want to be equilibrium, want to make a balance. The pressure for this side, right side, more than the pressure for the left. Now we are in equilibrium. Both two sides are equal. This work to make a shift for this direction, for the left direction. Another one, this amount for the left side increase. No equilibrium. So when it moved to the other side, good, there is equilibrium now. Why? To make shift for equilibrium for both direction. When I remove one, it back one, and when I remove the other, back again. Why? To make equilibrium. There is no equilibrium now. Now work for good for the left side. Why? To increase and shift equilibrium. No balanced now. No equilibrium now. The motion, now equilibrium. Good side and move in this direction. Look at the other. there is no equilibrium. I work for the opposite direction, right side. Why I do that? No equilibrium. Move the other side, left side. Add. So a change in pressure now has an effect also for a changing direction. Look at this. When we have an example for a changing for the pressure, you must know obstacle reaction. What this reaction? When I get A plus 2B, any two substances for both direction will be C plus D. Now, the pressure here increase. When the pressure increase, what about the volume decrease? So, less space. Equilibrium will shift to this side of the reaction. For the other one to make a balanced pressure increase. Now, shift to this side, this left side, to make a balance for this reaction, to make equilibrium. Other side, when the increasing the volume, more space. It means equilibrium shift for the right side. Why? To be equilibrium. Increase in pressure to the side with fewer moles, decrease in pressure to the side. Look, next one for the next lesson about the equilibrium. Good to explain that. This is temperature. Le Chatelier explain the temperature when the system at equilibrium is